Okay, welcome everybody. We're doing a Truss calculation here. It's my last day out of school, and I'm going to do a little work on my iPad here from home. I'm trying this out, so if I have some technical difficulties with this application here, bear with me, but I think it should be a nice teaching tool here. I've got a truss here. It should look fairly familiar to you. It looks very similar to one we did in class. It's slightly different. The one we did, oh my goodness, that eraser is too big. The one we built in class looked like this, okay? We're looking at support beam, a member going in this direction, which, hey, may change things slightly. I've also got some intriguing forces here. I've got a horizontal force and a downward force, so that's going to make it a little bit more challenging. So what we want to, of course, solve for is all of the external forces. Okay, that's the first thing we're going to do, and the second thing is all the internal forces. Okay, going to be good stuff. So before we can do any of that, I have to start kind of a phase zero here by figuring out if my truss is statically determinate. Okay, and how are we going to do that? Well, we're going to use a simple formula. 2j equals m plus r should sound familiar to you. All right, let's take a look at all of our joints. We have 1 joint, 2 joint, 3 joint, 4 joint, 5 joints A through E. That's going to make 2 times 5 equals the number of members. Let's use blue here. 1, 2, 3, 4, 5, 6, 7 plus the number of reaction forces. Well, I have a pin support right here. That's going to be 2 reaction forces, and I have a roller support here. That's going to be 1, so it's a total of 3. And guess what? I'm all good. Okay. In this video, we're just going to do phase 0, the statically determinate phase, and we're going to look at phase 1. We're not going to touch on the internal forces just yet. So I think I can kind of erase out this blue, all this color here, without messing up my truss. Oh, that's kind of nice. Okay, good enough. Good enough for remote learning here. All right, so let's go ahead and do phase 1. Phase 1, external forces. Now, here's where I would advise you to pause the video and try to solve for your reaction forces on your own. Okay, we've done this a lot of times. I will remind you we need to replace these supports here with some nice reaction forces. Remember, a pin support's going to get 2 of them. Here's RAY, and here's RAX. That should be flat, okay, my second period. Yes, that line is supposed to be straight, okay. Bear with me here. And this one, this roller support, is going to get 1, REY, okay. So there's your forces. You know what, that's even bothering me. I'm going to fix that. Come in here. Just touch it barely. There we go. See, if I had a application where I could do layers, this would be easier, which I do have one, but it's not as good at drawing. RAX, there we go, that looks better, and we'll add our little letter A there. There we go. All right, we feel good now. All right, so let's solve for our external forces, and I would recommend you pause and do this on your own because you absolutely can. Okay, if you're still watching, we're just going to continue and do it. Okay, hopefully you pause the video and you solve these. We're, of course, going to use a nice fancy set of formulas here called the static equilibrium equations. Let's see if I can spell. Woohoo, we're excited about it. We have the sum of all moments equal to 0, the sum of all x forces equal to 0, and the sum of all y forces equal to 0. All 3 of these things must be true. So we are going to use those one at a time in order to solve for our external forces. Let's start by looking at the sum of all moments equal to 0. Okay, so sum of all moments equal to 0. Well, how many moments do I have? Of course, first I need to pick my pivot point. Where is this bridge revolving around? And you know what? I'm going to pick point A. It's traditionally what we do. Just makes it easier. Okay, so all the forces at A are nullified because they're occurring at the pivot point. So how many forces do I have? I got one here, I got a second one right here, and I got a third one over here. So I'm going to have 3 total moments. Okay, and I can call them, simple enough, moment C, that's this one up here, okay, plus moment D, okay, that's this one right here, okay, plus moment E, and that's this force right here, the reaction force, okay, and all these should come to 0. Now let's think about positive and negative, okay, do a little right-hand rule. With our 500 newtons up here, we can see that that's going to lead to a negative moment. It's going to cause clockwise rotation. With moment D, this 1,000 newtons, that's pulling down, so I do my right-hand rule. That's also going to be negative. Look at that. Okay, that must mean that my REY is positive, and if I do the right-hand rule, rotating up like this, yep, that's going to be positive. So I can rearrange a little bit here. Moment E equals moment C plus moment D. Okay, just a little algebra there. Now, let's plug in our forces and distances, because we know a moment is just equal to force times distance. Okay, so we have something like Fe, let's just go ahead and plug in the force. So the force at moment E is going to be REY. Okay, oh my goodness, I did dotted lines. Don't do that. Takes so long to undo. There we go. REY times some distance. Okay, we're talking about the distance from A all the way over to moment E. Well, I can see that that's 12 plus 8, so that's going to be 20. Okay, that's my moment E. Moment C, okay, I've got 500 newtons. For those of you who like the metric system, you'll be happy with this problem here. Oh, no, don't scroll. There we go. 500 newtons times a distance of 12. Remember, I want that perpendicular distance. Okay, it would be 12 if it was this way too, but it's going to be the height, okay, which is 12. Okay. Let's see if I can erase this. Ooh, pretty good. There we go. I'll take it. Okay. And last, we have moment D. This guy right here. Okay. 1,000 pounds. Sorry, 1,000 newtons. And my distance of, well, the force is going down like this, so I must want this distance here. That's going to be 12 meters. Oh my goodness. Missed my whiteboard. This is just painful. There we go. All right, so I can start to simplify this. 20 REY equals 500 times 12. I believe that's 600. Okay, plus 1,000 times 12. Why? That's 12,000. And yes, this is 6,000. Okay, whoops. Okay, so 20 REY is equal to 12,000 plus 6,000. It's going to be 18,000. Divide both sides by 20. And I get REY is equal to, oh, look at this. I got my calculator right here. Divided by 20. Boop. 900. 900 newtons. And I'll go ahead and highlight my answers here. Isn't technology grand? Okay, I've got one of my answers. Let's go ahead and write that here. Look how nice that is. 900 newtons. All right, I still need to find RAX and RAY. I can go about doing that by changing which one of these static equilibrium equations I am looking at. All right, we just looked at Sum of all moments equal to 0. Okay, we did that one. We're good there. Now I want to let's look at the x forces. Okay, let's look at all the x forces in our truss here. So it's going to make a little dotted line here. You can actually scroll down. It's kind of nice. Can't do that with my whiteboard. Sum of all x forces equal to 0. How many x forces do I have? That's an x force. Okay, and that's an x force. I got 2. Okay, simple enough. RAX plus, let's see, we'll call that force of C equals 0. Okay, I know force of C is 500 newtons. Now, is it positive or negative? Why, of course, it's positive because it's pushing to the right. RAX plus 500 equals 0. So RAX, look how easy this is, guys, negative 500 newtons. Oh, yay, we did another one. All right, oh, look what that means I have to do. This arrow should be going this way. There we go. Okay, and let's go ahead and write that in here. 500 newtons. That should make sense. If I got 500 newtons over here, I know I gotta have 500 newtons over there. Okay, simple enough. Sometimes math is nice. Okay, last one. I did that. Now I need to look at all my y forces. Okay, dotted line here. Okay, sum of all my y forces equal to 0. Scroll down. How many y forces do I have? Well, I've got RAY, I've got this force at D, and I've got this force at E. So, RAY plus my force at D plus my force at E equals 0. Okay, RAY, we don't know whether it's positive or negative yet. Okay, FD is 1,000 and it's down, so that's going to be negative. RAY minus 1,000. Okay, REY is up, so that's going to be plus 900. Okay, equals 0. Folks, if you do just a tad bit of algebra here, I believe you will find that RAY is equal to 100 newtons. Okay, plus 1,000 minus 900, 100 newtons, and it's pointing up. And I do believe that that means we are done with phase 1. 100 newtons. Okay, we solved for all of our external forces. Next, we're going to do the internal forces in an upcoming video. I will catch you then.